I wanted a 10. What I will do is just apply the same file. So if you see here, 1 of 10 is running now currently. Up to date should be 10. Available is only 1. Rerun it. So if you see here, 10 of 10 is created. Up to date 10. Available is 10. Now if you do get pod, right, you can see automatically my 10 pod has been created. Today's session is for Kubernetes for beginners. So in this session, agenda would be introduction to Kubernetes and why exactly Kubernetes we use it, understanding the main Kubernetes components, which as a beginner, you should be aware of. Kubernetes is around 2015, it became an open source. It was basically developed by Google. It is a battle tested application. Google itself has built it and kept it. It was a secret tool for them. It had a rich features compared to Docker and other orchestration tool. Since it has a rich features, Kubernetes became popular. You can deploy application quickly and predictably. I mean, whatever you say to Kubernetes, it will do the same thing. Whatever it has been given in your YAML files or Helm charts. You can scale application quickly. It takes literally few seconds in order to scale it. If you wanted to scale a virtual machine, minimum it will take 5 to 10 minutes, depending on how if you automated your code. Third, the main point is you can roll out new features easily and very fast. So if think that there is a new feature is there, in order to roll out, it does it very efficiently. Issue is there. What you could do is you can roll it back as well. Roll out and roll back. Both the things you can seamlessly, you can do it. Kubernetes, it's basically a Greek word. It is a helmsman or a pilot. Even sometimes we call it as a K8s. K8s is nothing but the first letter and the last letter. In between, 8 letters are there. That is the reason we even call it as a K8s. Why Kubernetes? Well, in order to maintain your Kubernetes cluster, which user, is it a read-only user or a specific rule, can be handled using Kubernetes. Naming and discovery of services. For example, you can use private DNS. Kubernetes load balancing. If a service, if you make it as a service equals load balancer, automatically it will create a load balancer for you. If you have attached to, for example, AKS. In Azure case, it is a AKS, right? So it will create a load balancer as well. Using Kubernetes, you can monitor your resources, access and ingesting of logs, and debugging of application. It is a bit easier in case of a Kubernetes. There are a few commands are there. If you know about it, you should be able to triage a pod. You can easily find out what exactly is the error is. Those all the things you can do it. These are all the main advantage of Kubernetes. Why people are using Kubernetes? It's you can create your own Kubernetes cluster on your laptop itself. You can run a mini cube. It is so much portable that the code, whatever you write it, you can test it in anywhere, wherever you want, you can test it out. Kubernetes, it can auto place your pods. It can do auto restart. Think that there is some issue with your pod itself. It will in olden days, what used to happen is if there is a thing that if your application is not working, think that are around night 2 o'clock or something like that, people used to get up and used to work on that one. If the service is down in pod, automatically it it matches the desired state. Automatically it restarts it. So there is no human intervention is required. And scaling wise, you can set up a scaling. Think that your application, there is a lot of load is there. You can configure it in such a way that automatically it will scale it for you. It's kind of a on a autopilot mode. So there is no human intervention is required. Note that Kubernetes is a containerized IaaS tool, but it is not a PaaS service. Main components in Kubernetes, the first one is a node. So it can a node can be a physical machine, or it can be a virtual machine, or it can be your laptop as well. So if you are running in your laptop using Vagrant, you can spin up a 3-node cluster. A node is the one where exactly the pods runs. So it's basically it can be a virtual machine, it can be a physical machine, it can be even your laptop. Your node contains a necessary services in order to run your pods. Each node is managed by a control plane. It is the smallest deployment computing unit. In a particular pod, we can have one or many containers. Sometimes we have a maximum. usually in the IT field, we usually keep a couple or three, maximum three containers, not more than that. Otherwise, maintaining this pod itself, it becomes a headache, challenging for us. Usually, why we keep maximum of the cases, it would be only one container on one pod, one container would be running, maximum cases. Sometimes it can be a 1 to 2 containers or 3 containers. For the main container, you need a helper container. For example, in order to push the data to somewhere else, or some kind of agents which would be required for your pod to work in an efficient manner. For that reason only, we use try to use a helping container. Other than that one, we never go for a multiple containers for a pod. A pod is it inside a pod. If you think that if we have a 3 containers, so it shares the same network using a local host itself, it can talk. Each pod would be having a its own unique IP. A pod can communicate to rest other pod unless you have configured a network policies. Those all the bit, if you have configured it, then only there would be a, you can block it, block a communication between pod to pod. But by default, it would be open. That is, one pod can communicate to another pod. Kubernetes service is a logical group of pods based on the selectors. So if you could see here, there is a selector is mentioned, right? So Kubernetes.io name I had given as a proxy. So if there are 10 pods are running with this particular label, all those things, it would be considered as a one cluster. Kubernetes config map, it is basically a key and value pairs. Application is has any environment variable that that can be set as a config map, command line argument, or as a configuration file. Secrets, it can be a token, it can be a key, or it can be any specific username and password. So all those things you can keep it in a secret deployment. It's a higher level abstraction of pod basically. So as you could see this in this YAML file, in the template section, you would be mentioning the pod details. Main important aspect of deployment is the scaling. If you wanted to increase it from 3 to 30, just add a 0 over here and run this run a one particular command. Automatically, it will create a 30 pods. And again, you wanted to scale it down. Just decrease this particular number to 3023. Automatically it will reduce. So deployment and pod would be having a one-to-one relationship. Most of the cases in Kubernetes just YAML. For example, Ansible is also you can code Ansible in YAML file as well. Kubernetes also you can code it in YAML file. That is the reason most of the places, if you know the YAML syntax, even in Azure DevOps pipeline, right, we use YAML itself. There are few things we should remember as a DevOps or IT engineer. The YAML file extension is always .yaml, YML or YAML. It's one and the same. And YAML is case sensitive, and there are few indentation is there. You need to refer it. Always it is two spaces from parent to child. I'll just show you here. For example, metadata under name is a child of a metadata. So if you see here, n is after the two spaces basically. These are all indentation. We need to follow it. A list would be denoted by hyphen, and if there is a key and value, we use colon space, key and value related bit. Why we use YAML? It's a bit easy to understand. If you see the file, as an engineer, you can understand the flow of what exactly it has been written. 99% we try to make our infra as a code. So that is the reason we try to use YAML files, so that you can keep those YAML files in any versioning tool such as a GitHub, any tool, so that keep track of management of all those files. That is the reason we tend to use YAML file. Normal any configuration. So these are all the components would be having all these details basically. So API version is nothing but the pod is running on which version. Second one is kind. Kind means which type of a Kubernetes resource we are deploying it. In pod case, it would be pod. In deployment case, it would be deployment. But if you see here, API version is apps/v1. Config map I said, right? So if you see here, API version is v1. Kind is config map. So next one is basically a metadata comment, basically a description. This one is the main bit for the pod. This would be used for servicing. As I said earlier, service is used for a logical grouping. For that purpose, it would be used. Which service uses it in order to group the relevant pod? So this is the, so next one is specification. So for the pod perspective, a specification, what all the things it is required in. It requires a containers name we give it. This particular image is currently I'm running Nginx in Docker Hub. This under this repository there is a image is present. I'll just show it. If you see here, this has these many versions. I can deploy 1.0, 1.1, 1.2. In my code, what I have mentioned is, if you want to specify any other external repository or internal repository, it will by default it will go to a Docker Hub itself. Okay, so what it is doing is this particular Beginner Academy, this particular image, and this is the version, that is the first version it is using it, and it will download it. This is a Nginx kind of a Apache. It's a web browser base, and what I've told is container port should be running on 80 port itself. This is the specification of a pod. Let us run this and test it out. So if you see here, when I say kubectl get all, only one, the default whatever Kubernetes has installed it, this particular service it is showing it. Other than that one, there is nothing is there. So in order to run this create this particular pod, right? So the command what I would be using is, so I'm in this particular path where all my YAML files are present. If you wanted to run this particular code, the simple command is kubectl. If I do a apply -f and give the particular YAML file name. If I do it, kubectl, it created that particular Nginx basically. If you see here, it said pod/Nginx is created. So let us now rerun the old command. Get all. It is running. Earlier only this default service was there. Now you could see. Now you could see under pod Nginx is in a running state. It took around 18 seconds to run it. So if you wanted to check only only pod, so what we do is kubectl is the first command. Next is the verb. It can be a get. It can be rest other commands. If you wanted to delete it, you can give those. But so get. I wanted to get all the pods running in this particular cluster. If I run this particular command, I would be able to see only the pod data. kubectl describe pod can describe that particular pod from where exactly it is running it. So if you could see image ID, it is using Beginner Academy, and all the details it would be showing it. The port details from port 80 it is running it. All the rest of the details related to pod, you can view it using this particular command. So think that you wanted to delete this pod itself. So command is basically, if you do delete pod Nginx, it would be deleted. If you see here, nothing is there, nothing is running. And if you wanted to rerun it, if you rerun the same thing, it will show you that particular pod again. If you rerun it, automatically it will create it for you. The pod is created now for us, right? The labels, if you could see, it is using a label proxy. Let us click on service. Okay. So here, if you see, the service is as I told you earlier, service is a logical grouping of all the pods. What it does is, there is a selection it does it based on the criteria, whichever pod has this particular labels, it will group it and make it as one cluster. So if you see, this particular pod is having the same thing. What it does is, this service has this particular selector. This is the condition base. So here also API version is there, kind is there, kind is the service. Metadata you can give whatever you want. The name it will display you. I'll show you when I run it. If you wanted to search existing services, right? Command is kubectl get service. Currently default one is there. Can type completely, or if you're a bit lazy, what you could do is get svc. That also gives the same result. Now if you could see only one is running, default one it is there. Let me clear it out. So this is the name I have given it, that service name. Again, the port mapping, what I'm doing is 80 port, target port is this particular name, whatever I have given it. It has a interlinking. Let me run that as well. Apply. So apply -f. So I'm trying with, I wanted to deploy services. So if you see service got created. So let me see get service. So if you could see, there is a new service is created for me. Test your application port forwarding. This is since I'm testing it in my local laptop, I'm doing a port forwarding 7080 from my browser to my container port. Okay, so it is enabled now. So what I would do is I'll just open my local host 7080 port. I'm running it. So if you see here, my Nginx displaying this particular message. As I said earlier, if there is a need, your particular pod wants to consume a few data from a config map. Okay, so what I have done is, whatever the last example, Nginx 1.4, it was display this particular data, right? So I wanted a different data. Just mention beginner academy Azure initial session on K8. Okay, this is our config map. Adding this particular data, what it is happening is the same image, this particular engine index.html resides in this particular path on this particular image. Basically, I'm overriding with the config map. So there are two things I have done. I have volume, I am mounting it from a config map. Okay. So if you could see here, the name volume mounts, what I've given is the index. The volume name is also, it should be same. Okay. Whatever the name we give it. In the config map, I have referred it to BA config map. BA config map is this one. So if you, I'll just mention it as AKS config map. If you mention whatever the name you give it here, you should mention it here as well. Okay, it's just a reference. Pod related bits are same. Only if you remember, the labels I have mentioned it as a CM. Created another service over the selector name. I have given it as a CM. Okay, service is used to do a logical group of a pod. In order to run this particular pod, so what I need to do is first deploy config map, and then pod, and then service. This is the sequence it should ideally we should do it. We can keep all this in one single YAML file as well for ease of our reading purpose. We usually keep it in separate itself. Just apply pod. Pod is created. So now service. Service is also created. So let us check what all the resources are there. Get all. If I do, if you could see here, CM pod is created. So can get the config map. Yeah, if you see your config map, AKS config map is there. A new service is also created, right? So all this thing, it has been done. So if you see here, was the last one. Yeah, if you see here, whatever config map it is there, it has been displayed over here. Let us update, what is today date? 20th May, right? Let us update it by 20th May. Okay. So let me add it here. kubectl apply -f cm, right? cm.yaml. Okay. I have updated my config map. So let us rerun it. So if you see here, it is not getting reflected. Okay. So reason being is the volume is already mounted on that particular pod. So in that case, what we need to do is cm underscore pod, just delete it off, delete the pod. Okay. Pod is deleted. Let us recreate it. Okay. Let us do a port forwarding. If you see here, the 28th May is displayed over here. So in this way, you can make the change, but the caveat is pod has to be restarted. Config map is mounted. That is the reason. Okay, let us do a deployment. Deployment concept wise same only. So now replica. Let us do a replicas one. Okay. So let us do a replica one. So kubectl get if you do a deployment, get deployment, nothing is there on this particular cluster. Okay, so let us do a engine next. Mention 29th May, just say May. So let us run the apply kubectl apply -f deploy. So if you see here, get deployment is created. Okay, as I said earlier, deployment is one level above of a pod. So if you see here, earlier whatever I have created, the name it was coming up. In deployment case, the name whatever we have given it, it will append some random numbers and run our pod. Okay, so now if you see deployment specification wise, it is expecting ready one pod should be running at any cost. One of one, both are running, right? So update, if there is an update, it will show what deployment does is it checks the desired state, what is there, and it makes sure that that is up to date. Okay, so now let us increase it. I wanted a 10. Okay, so what I will do is just apply the same file. So if you see here, 1 of 10 is running now currently. Up to date should be 10, available is only 1. Okay, so let us rerun it. So if you see here, 10 of 10 is created, up to date 10, available is 10. So now if you do let us clear it so that we can see clear. Now if you do get pod, right, you can see automatically my 10 pod has been created. So this is the way you can maintain it, right? So think that I wanted to delete few. Accidentally someone in your team deleted it. Okay, delete pod. Let us delete few. Okay, it is starting to delete. Earlier pod I had mentioned, forgot to mention it, so it deleted it. So if you see here, automatically it recreated those deleted. If you could see here, how do you compare it? This particular pod, it is 10 seconds ago it has been restarted. Here also, this also you can see 10 seconds ago. So automatically if someone deletes it also, Kubernetes will understand that it is not up to the mark. It was supposed to be 10. What it checks is, it checks a deployment. It is supposed to be 10, up to date should be 10, available should be 10. If there is someone deletes it, automatically Kubernetes scales it up to make sure all the 10 pods are running. That is the way, that's the beauty of Kubernetes.